And welcome my wonderful honor students for your beginning of boot camp training in graphs. This is Mr. Jockmans asking you to have your notebook out like always. If you want to start a whole new section called the graph section, that's perfectly fine with me. This video today is to give you a little sense of what to expect on the graph sections, as well as giving you a number of really important clues, tips, strategies, and one very important table you're going to be adding in. So, at this case, if you have a set of colors you want to use them. You're going to take up a little bit of space in your notebook, maybe like 1 or 2 pages, and that's perfectly fine. So here we go. Today's video is first going to give you one little more thing about acceleration, which you think is important. And then we're going to go a little in depth about displacement, velocity, acceleration, how to get them from graphs. So the first thing I want to do with you is just kind of confirm from what we did last time with velocity and acceleration. I know some people are having some trouble figuring out if acceleration is positive and negative depending on which way things are going. So here's the scenarios. If something is speeding up, either speeding up forwards or speeding up backwards, the velocity and acceleration always be the same sign. So if it's going forward, the velocity is positive, and speeding up, acceleration is positive. If it's speeding up backwards, velocity is negative and acceleration is negative. Now, if something is slowing down, they're going to be the opposite sign. So for example, slowing down forward, positive velocity, negative acceleration. Slowing down backwards, negative velocity, positive acceleration. If you want to pause the video and add those into your little scenarios you have at the bottom as a key idea, go right ahead. So what I'm going to do is I'm going to discuss kind of 5 major strategies or things to think about when it comes to graphs. And this is the meat and potatoes of the video. So the first strategy is, there are only 3 things you can do with a graph, whether it's in physics class or math class. The first thing you do is just look at the y-axis and go directly across until you hit the line and read off that value, and that'll get you a number. The second thing you're going to see is we could take a slope. We could do that either for the entire graph, looking at the start and end point, or we can do it also for a small segment. So in this class, we're going to have graphs where we look at just small slopes parts, as well as the entire thing. And the third thing is we could find the area underneath a line or curve. Again, we could do it for the entire graph or just a segment. These 3 things are how you are going to constantly succeed with graphs, whether in physics class or trig, calculus, whatever math class you're possibly in. So the second strategy is pretty important. Always identify the kind of graph it is based on what's on the y-axis. So there are 3 types of graphs. The first kind of position graphs, you see meters on the y-axis. When you read it off directly, you'll get displacement. The second type of graphs are velocity graphs. Instead of meters, you'll see meters over seconds on the y-axis. And the third and super rare type, acceleration graphs, where you see meters per second squared on the y-axis. There is nothing worse than like going through a situation and figuring out what you think you know on the graph, and then realize later on when you get the quiz back that you accidentally looked at the wrong type of graph because you didn't look at the y-axis. So this is your first major thing to do. The third kind of strategy, but I'd say more idea, is even though we're going to do some calculations based on the graphs, quite a bunch eventually, you're going to have to do a lot more in terms of being able to understand what is actually happening, whether something's getting further away or closer, speeding up or slowing down. And so here's the strategy. Never just automatically go to the math. If you look at a graph and a moment later you picked up your calculator, you're doing it wrong. And you're hurting me as a human being. And I will go home and cry in my ice cream because you are not thinking like a scientist. Always figure out how the object is moving from the graph before you do the math. Figure out, is this position, velocity, speeding up, slowing down? It will help you out, I guarantee. Strategy 4. Graphs allow you to determine the displacement, velocity, and acceleration from each other. So there are going to be 3 ways of doing it. Again, direct reading, slope, and area. Now here is the all-important table you're going to be copying down right now and probably pausing. So I'm going to wait about 10 seconds and I'm going to explain what exactly it means. Don't worry, I'll wait. Cool, I'm done waiting. Let's look at the position graph. If you see a position graph and you look and to read it directly, you will get the position. If you take the slope of the position graph, you will get velocity. If you find the area, it'll give you nothing really. So with the position graph, you can either read it or find the slope. Now, a velocity graph. Think for a moment and get ready to answer. What do you see on the y-axis? Meters per second. Nice job. If you read it directly, you will get velocity. If you take the slope of this graph, you get acceleration. If you find the area underneath, you get displacement. You can also see how I did it mathematically through division and multiplication. And if you have an acceleration graph, super rare. If you read it directly, you'll get acceleration. If you take the slope, you get something called a jerk, which is we only deal with in physics. If you take the area, you get velocity. So with this, the one of these that's probably the most important is the velocity graph, because you can take the slope and area of it. And with the position, which is the second most common, the slope is also the only other thing you could do. So to finish up, with velocity graphs, keep in mind you can do both things. Furthermore, if you read it above the positive x equals 0 line, you get a positive velocity. If the line is below it, you get negative velocity. And as you're going to see, an area underneath the curve that's negative is a negative displacement. Now you're like, what the heck, Jock? I need to see things. But I got your back. Don't worry about that. Here's a little velocity graph. When I say direct reading, like if you're trying to find the velocity at, let's say, this time right here, you go up, you read over, you get a positive velocity. It's a direct reading. Looks like this ends with a negative velocity. It starts with a positive velocity. You can see right here, it's kind of like in two different segments. In the first bit, it starts off positive, and then at this time it ends at 0. In the next bit, it starts at 0 and ends at a negative velocity. When you take the area of the curve, so in the first little bit of time, from 0 seconds to whatever time this is the area under the curve. That area is the displacement. And since it's above the 0 line, it's a positive displacement. Now if you take the slope of this line, you'll find the acceleration, because the slope of velocity is acceleration. Now, from this time to this time, you can see the area between the 0 line and the line is actually below the 0 axis. Or in other words, this area in pink is below the 0 line. That means it's a negative displacement. So combined, how much total displacement is there? Well, these look about equal. This is positive, this is negative, so it kind of cancels out. The overall displacement is 0. And with that, my wonderful students, that's the start point. I want you to please now, if you don't mind, take a couple moments, maybe like about a minute or two, and write down questions to ask me in class during tomorrow's experience. Because even though we're going to go over a lot of this in class for the next like 2 or 3 sessions, if you're having trouble starting it off, it makes it a lot worse, and I want you to succeed. Write down your questions, ask me in class or individually, and I'll be happy to help you out. Until next time, have a good time.